Hello and welcome to another not quite episode of How to Understand X. I think this one will be a fun one. We are going to do one of my favorite derivatives of all time, and that is the derivative with respect to x of ln of x to the power of e to the power of x to the power of e to the power of x. Alright, this, I won't lie, this is an intimidating function, and I think it is difficult. It is difficult. I won't lie and say it's not difficult, but I think if you understand the rules that you are going to apply and you apply them properly, you will be totally fine. This, I think, with a little bit of preparation, I think any Calculus 1 student could do this if they genuinely wanted to. And I'm going to prove that. Our final answer is not going to look pretty. It's going to be a very ugly final answer, but the way that we got to that final answer, I think, will make a good amount of sense. So, to simplify automatically, we need to make this come out into the front. ln is a continuous function so that we can use any power of like x to the power of something in an ln function, and we can bring that power outward. So this is going to be the derivative with respect to x of e to the power of x to the power of e to the power of x times ln x. Already, you might be saying, okay, that's not too bad, and that's what I want you to say, because you know the derivative of ln x, you know the derivative of e to the u, hopefully, and that is u prime times, not equals, u prime times e to the u, and the derivative of ln x is equal to 1 over x. So automatically, you might be seeing that there's stuff that we can do. But before we get into the actual differentiation, we need to look at one relatively important proof, or it's not really a proof, I'm just going to kind of show it to you, and that is the derivative of f of x to the power of g of x is equal to f power f to the power of x to the power of g of x times ln of f of x times g of x in parentheses prime. Alright, that's a intimidating function, I will not lie, but I think it makes sense, right? Because we can write, I'm going to use f and g instead of f of x and g of x. I mean, they both mean the same thing, but I just want our work to be slightly less cluttered. So, using our understanding of inverse functions, we know that e to the power of ln to the power of anything, we can say anything, is equal to that anything. So, if we were to say, maybe we have e to the power of ln f, that is equal to f. So if we have f to the power of g, then e to the power, let me write this in a more coherent, flow. So we have, whoops, there we go. We have e to the power of ln f is equal to f to the power of g is going to be equal to f of g, what we are trying to derive. So we're going to have this derivative is equal to that derivative. And now, I think it's relatively self-explanatory. I mean, like, from here, we can use our e to the power of u derivative, and that is equal to u prime times e to the u. And when we do the derivative of e ln f to the power of g, we can simply distribute that g onto that ln f because e is the same base. So we're going to have e g ln f times the derivative of u in this case, which is simply ln f times g prime. And we can rewrite this. Again, we will simply cancel out that e and ln, and then we're going to have f to the power of g. That g is still going to be our power. And yeah, that's our original power rule. I didn't do anything. I just maybe manipulated it slightly so that we can use one of our existing rules, but that is going to be our only proof of the day. And past that, if you know product rule, if you know the derivative of e, if you know the derivative of ln, I think anybody could do this problem now. So let's do it. We are going to do the derivative of e to the power of x to the power of e to the power of x times ln x. So obviously these are going to be two different functions. We have that and we have that, so we are going to need to use power rule. So just as a reminder, that would be uv in parentheses prime is equal to u prime v plus uv prime. So we're going to have the derivative of this times that plus that times the derivative of this. So when we plug everything in, we are going to have, undid a little bit too much. We're going to have the derivative of, well, actually, yeah, we're going to have the derivative of e to the power of x to the power of e to the power of x. I'm going to switch between the derivative with respect to x and prime notation because, I mean, I don't really like, sticking to either. I mean, both, like, you know what both mean. So, times ln x, which is going to be our v, plus e to the power of x to the power of e to the power of x times the derivative of ln x, and that's going to be 1 over x. So yeah, I think I did a proof of that already in my derivatives video, but if I hadn't, I will do some proofs for some other like derivatives that I think are interesting. So we will have times 1 over x. Now we are going to do another e to the u thing. So let's rewrite what we have so far. We have the derivative of e to the power of x to the power of e to the power of x times ln x plus e to the power of x to the power of e to the power of x all over x, right? And then we will do the derivative of this, and yeah, I mean, this will have a prime. I was wondering why it looked a little odd, but yes, we're going to do this, which is, again, e to the power of u is equal to u prime times e to the u. Our u in this case is going to be x to the power of e to the power of x. So we are going to have e times x to the power of e to the power of x times x. Oh, I forgot to mention, I want you to actually write this down. I might, go a little bit fast, but I swear if you just write down every rule that you are going to use, and I mean, maybe you can highlight it in different colors, just like where you use each rule. You can just look step through step, and you will get what's happening. This is going to look crazy because it is crazy, but if you actually write it down, you will understand what's happening. I'm pretty sure you will. But yes, we are going to do this, which is going to be our u prime times ln x plus e to the power of x to the power of e to the power of x all over x. Now, this is going to look like our, our generalized power rule. So that's going to be f of x to the power of g of x is equal to f to the power of g, let me put prime, times ln of f times g prime. So, yep, let's plug that in. Our f in this case is going to be x, and then our g is going to be e to the power of x. So we will have e to the power of x. Actually, x to the power of e to the power of x. We're going to write down our generalized power rule. So we're going to have f to the power of g prime is equal to f to the power of g times ln f times g prime. All right, f in this case is going to be x, and g in this case is going to be e to the power of x. So let's plug that in. We will have this is equal to, we're going to have our x to the power of e to the power of x still in the front. So this is going to be times x to the power of e to the power of x, and then times the derivative of ln f, which is x, times g, which in this case, forgot to put ln of f, which is x in this case, times g, which is going to be e to the power of x in this case, prime. And then again, this is going to be times ln x plus e to the power of x to the power of e to the power of x all over x. Okay, already I think this is looking pretty okay. I think we know what to do from here now. This is just going to be another simple product rule. This is going to be our u, this is going to be our v. So we're going to have e to the power of x to the power of e to the power of x times x to the power of e to the power of x times the derivative of u, which is going to be 1 over x, times v, which is going to be e to the power of x, plus u, which is going to be ln of x, times the derivative of v, which is going to be, again, e to the power of x, times ln x plus e to the power of x to the power of e to the power of x all over x. Okay. And from here, that's it. That's our answer. There's no, impactful way to simplify it. Let's just write it without the multiplication signs. And we will get x to the power of e to the power of x times e to the power of x to the power of e to the power of x times ln x times e to the power of x times ln x plus e to the power of x over x plus e to the power of x to the power of e to the power of x all over x. And that's going to be the derivative of ln x to the power of e to the power of x to the power of e to the power of x. All right. Honestly, that was relatively simple, and I hope it shows you how difficult calculus may seem, but when you understand what rules you are using and how to apply those rules to complicated functions, you can break down some pretty intimidating ones. I mean, look at this. This is 4 exponents, right? And it's an ln function with alternating inverses. It just seems, well, it doesn't seem impossible, but it does seem very difficult, at least on first glance. But once you understand what rules you're going to be applying, I honestly don't think it's too difficult of a derivative. And yeah, I mean, this is a short video, but I hope, even if you, well, I honestly don't think anybody wouldn't be able to follow along as long as they, write down the rules that they were going to use, maybe even highlight when you use those rules, and like write down the generalized power rule. Like if you haven't seen that proof before, that might be, a bit odd. But yeah, I mean, I felt like that was a relatively okay derivative. And yeah, on that note, I'll recommend a song. I don't know what I have been listening to recently. I've been listening to the Shang-Chi soundtrack a lot, but I have also been listening to Coda the Friend a lot. So just going to recommend one song, and that's gonna be uh, BQE by Coda the Friend. I'm not doing an album today because, this wasn't an album's length of video. So this is going to be BQE by Coda the Friend. This is a posse cut with, I think it's Boss and Joey Bad A Word. Can't say that on an educational video, but it's just a good song. It does have that very New York feel, but it also has that modern flair that I think, you know, does bring a bit of life to the original posse cut. So, it's good, has a nice instrumental, some funny one liners. I think Boss has a lot of charisma, Coda has a lot of charisma, Joey has a lot of charisma. It's a pretty good song. So, yeah, on that note, uh, goodbye. I feel so weird not dragging a video on for literal hours, but I don't think there's much more to talk about it. This derivative, while it is a relatively difficult derivative, especially for Calculus 1 students, and seeing where you can manipulate functions to make it into familiar functions, I think it's okay, you know? So, yeah, bye, and what's the exercise that I'm going to recommend? Do a lap. Yeah, just do a lap. I'll come up with something more creative later. Alright, bye.